So let's take a look and derive the expression for the Reynolds number. Okay, so this is the thing. So let's continue with this too, and then we are set. Although not that set. Okay, anyway, so yeah. So to find Reynolds number, you're gonna use this equation. This is the very equation they're gonna use for a pipe. Remember, this is for a pipe. For a pipe, there's a different Reynolds equation, so you're gonna remember. For a pipe, we're gonna use this one. For a non-pipe system, okay, so for a non-pipe, we're gonna use the length, okay, rho v length equals to over nu. So if the comparatively, if it's a pipe, we're gonna use rho vd over nu. Okay, so you're gonna know which one to use. Okay, for the pipe, make sure you take in the diameter. For non-pipe system, you're gonna take in the length. So the length of the whatever thing you have. In this case, it's F1. But anyway, so let's continue. So in this case, it's a pipe, so we use the diameter. Velocity, make sure you know that this is average velocity. You make sure you can put inside your brain. Okay, inside your brain, 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 average velocity. Okay, sweet. So this one is what? This one is it's called your density. Okay, this is density, and then this is your viscosity, dynamic viscosity. Okay, so you're gonna sub in. So minus rho 2r. Okay, why is it 2r? Your pipe is r over here from this point to this point is actually r. Okay, so this point at this point is r equals to r, right? So however you're talking about only this side, you're not talking about this side also. So in this case, this is also another r equals to r. So therefore, you have 2r as a diameter. Okay, so 2r. Okay, this is the diameter, and then you know your average velocity. So last video we talked about your average velocity. If you still remember, uh, we derive this portion over here. So you want to compare. It's the same portion, r square, 8 nu, partial p partial x, and then there's a negative up front over here. Okay, so this negative belongs to this average velocity lah. Okay, so density and the viscosity still stay the same. I will not change it anyway. So it's like that. Okay, so if you were to multiply them together, okay, I'll multiply all of them together. Mu times 8 nu, you have nu square over here, right? And then since 8 divided by, so 2 divided by 8, you got 4, so it's 1 quarter, so that's why you have a quarter nu square over here. Okay, and then what we have, so we have minus rho r. Okay, is this r? Oh yeah, this is r, so it is r cube, I think. If I'm not wrong, this should be r cube. Okay, so it should be r cube over here. Okay, so this is r cube. So it's minus rho r cube divided by 4 nu square. Okay, and then partial p partial x is the same thing. So therefore, we have found the Reynolds number for that. Take note that this is a non-dimensional number, meaning there's no SI unit. It's just a value to show you. And then, so this is actually the entrance length from here to here. What does this mean? When the fluid comes in, you see is all they comes in the same velocity. However, when the frictional over here it starts to drag all this thing, and then it goes more and more. So this part is gonna become more and more maximum velocity, as you can see. It's gonna win. It's gonna win the war, that kind of thing. So because of the frictional over here. So as you can see, when it reaches here, when it cross over this length, so this is the entrance length. After which you will become fully developed. So you always keep the same. So throughout. Okay. So this is actually what this means for entrance length. Entrance length is to introduce the amount of fluid up till it goes to fully developed. When it goes to fully developed, that's it. Okay, it's the same throughout. It's constant. Okay, so entrance length. So how do we calculate it? The entrance length, if you were to calculate, is actually So the entrance length is actually calculated using this formula, which is the Reynolds number divided by 20 times the diameter. Okay, so if you look at it, okay, so Reynolds number divided anything divided by 20 is how much? Okay, let's say 1 times 1 divided by 20. Okay, why do I do so? Well, 1 divided by 20 times RE is also RE divided by 20. You get what I mean? So I'm going to show you 1 divided by 20 is about 0.05. Okay, so what I mean is that maybe I should drag this thing over here, and then so what I mean is 1 over 20 RED, right? So this, as I proved to you, 1 over 20 is actually 0.05. RED is actually 2 radius. In this case, I've already explained that this is 1 R over here and then another R over here. So there's 2 R for the whole diameter. Okay, so this is 2 R. So this is approximately 0.06. Okay, so 0.05 or 0.06 is about the same. Okay, so this is just a thing that there's a little variation, but this is what is okay one. So just use 0.06 or 5 is okay, no problem. So you have this value. So this is your Reynolds number. Okay, so this is laminar. Laminar, you use this one. Okay, this is thing is in your book lah. Okay, yeah, I don't know where, but yeah, anyway. So never mind, it's not shown. So I would recommend you go and memorize this one. Okay, so memorize. Okay, same as this one. Okay, average velocity, memorize. Okay, so let's continue. So this is actually 2R, which is shown over here, and then this is 0.06. This is your Reynolds number. Okay, this Reynolds number comes from where? Comes from here. Okay, it's actually this one. I will bring this down. Okay, exactly the same, just that previously I found out that it should be cube. Okay, because minus rho 2r over nu. Okay, multiplied by the velocity. Definitely you can get r cubed. Okay, so this is just a mistake. But anyway, so once we reach here, okay, so this is your 0.06 Reynolds number times diameter 2r. So if you were to multiply them together, okay, so let's see. Okay, so we have 2r over here. So r cubed times r, you have r4, right? So this one times this one, and then 2 times 1 over 4, you have half, right? So I've cancelled away. I've cancelled away this 2. So what do I left? I have minus rho nu square, and then 0.06. Maybe I should put over here also. And then partial p partial x. Okay, so if you were to look at it, this is exactly the same, minus 0.06. Rho r4, in this case, this is definitely r cubed. Okay, so this is r4 definitely. Because r cubed times r is r4. If it's r square, if your times r is, I think you get what I mean already. So definitely this is r cubed. So over 2 nu square, it's the same thing, partial p partial x. So this will end the portion of example 2. Derive the expression for entrance and Reynolds number. So I'll see you in the next video to do out this one. Okay, this is an additional thing. So I'll see you there. Bye bye.